You hear blockchain thrown around all the time, right? Bitcoin, NFTs, it's everywhere. But what does it actually mean? How does this thing work? Well, welcome to the Priyank Gada channel. Today, we're gonna cut through all the noise and build a blockchain together, right from scratch. Super simple. Okay, so here's the plan. First, we'll tackle the big one. What even is a blockchain? Then we're gonna zoom in and look inside a single block. After that, we'll see how they all link up to form that famous chain, figure out what makes it so secure, and then, at the end, we'll talk a little bit about where this tech is headed. All right, first things first. What is a blockchain? Let's dive right into that big question. Because even though it sounds super complex, the basic idea behind it is actually surprisingly simple. I mean, the name really gives it away, right? It's a chain of blocks, and these blocks contain information. When you put them all together, you get what's called a distributed ledger. Now, what that means is it's a record book that isn't owned by any one person or company. It's totally open. Anyone can look at it. And here's the kicker. Once you write something down in it, it's pretty much there for good. Changing it is, well, almost impossible. And what's kind of wild is that this tech isn't new, not at all. The original idea actually came about way back in 1991. The goal was to create a sort of digital notary, a way to timestamp documents so you could prove they hadn't been messed with. But then, nothing. The idea just sat there for nearly 20 years, until 2009, when the mysterious Satoshi Nakamoto dusted it off and used it as the foundation for, you guessed it, Bitcoin. Okay, so we've got this chain of blocks, but what's actually in one of these blocks? Let's crack one open and see. So every single block is made up of 3 key ingredients. First, you've got the data. For something like Bitcoin, this would be the transaction info, who sent what to whom. Second, each block has its own unique hash. And third, and this is super important, it contains the hash of the block that came right before it. Okay, so that second piece, the hash, this is absolutely crucial. The best way to think about a hash is like a digital fingerprint. It's a completely unique identifier for that specific block and everything inside it. Just like your fingerprint is unique to you, this hash is unique to this one block. And this is where we see the first layer of security. See, the second a block is created, its unique fingerprint, that hash, is calculated. Now, if someone comes along and tries to change anything in that block, I mean anything, even just one tiny character, that fingerprint changes completely. It's an immediate, blaring signal that something's not right. All right, so we know each block holds its own fingerprint and the fingerprint of the block before it. So how does that simple little detail create the entire chain? It's actually really clever and super simple. Each new block essentially points to the one before it by holding its fingerprint. So block 3 has the hash of block 2 has the hash of block 1, and so on, all the way back to the very first one, which they call the genesis block. That connection, that pointing back, that's the chain. Okay, so let's see this security in action. Let's say a hacker tries to tamper with block 2. They want to change the data inside it. What happens? Well, the moment they change that data, the fingerprint of block 2, it changes instantly. It's not the same block anymore because its digital DNA has been altered. And this is where the whole thing just breaks. It sets off a massive domino effect. Think about it. Block 3 is still holding the old fingerprint for block 2, but that fingerprint doesn't match the new tampered block. So the link between them? Broken. And because of that, block 3 is now invalid, and so is block 4 and block 5 and every single block that comes after it. The whole chain just falls apart from that point forward. But hold on a second. You might be thinking, couldn't a smart hacker just change block 2 and then really quickly recalculate the fingerprints for block 3, block 4, and fix the whole chain? And yeah, they could try. That's why blockchains have a couple more tricks up their sleeve. Let's talk about the real security fortress here. So just having those fingerprints isn't quite enough. A powerful computer can calculate thousands of them in a second, so fixing a broken chain would be way too easy. To stop that, blockchains add something called proof of work. You can think of it as a really hard math problem that a computer has to solve before it's allowed to add a new block to the chain. It's designed specifically to slow things down. And we're not talking about a quick Sudoku puzzle here. For Bitcoin, it takes the combined power of the entire network around 10 minutes to solve this problem and add just one new block. So now think about our hacker. they wouldn't just have to tamper with block 2 and recalculate its hash. They'd have to do the 10 minutes of proof of work for block 3, and then another 10 for block 4, and so on, for every single block after. All while the real network is still adding new blocks ahead of them. It becomes practically impossible. But there's one more layer, and this one is the real game changer: distribution. See, the blockchain ledger doesn't live on one central server. It's not in a bank vault somewhere. Instead, it's shared across a massive peer-to-peer network. Everyone who joins gets their own complete copy of the entire chain. It's like everyone has their own copy of the same book. So here's how that works. When a new block is ready to be added, it gets broadcast to everyone on the network. Each person's computer, we call them nodes, takes a look at it. They check its work, make sure the fingerprint is right, and that nothing's been tampered with. If it all looks good, then everybody agrees to add it to their own copy of the chain. That mass agreement, that's called consensus. And this right here is what makes the whole system a fortress. To get their tampered block accepted, our hacker would have to create their own fake chain, redo all the proof of work faster than everyone else, and then convince the rest of the network that their version is the real one. To pull that off, they'd need to control more than half, over 50% of the entire network's power. It's called a 51% attack, and it's so incredibly difficult and expensive that it's practically impossible for major blockchains. So let's recap. We've got this system that is super secure, totally transparent, and isn't controlled by any one person. It's pretty amazing. Now that we get the how, let's talk about the why. Why is this so much more than just a way to make digital money? Because this whole idea of a secure, unchangeable, shared record book, you can apply that to so many things. People are talking about smart contracts that automatically execute themselves, like releasing a payment as soon as a package is delivered with no bank needed. Or think about your medical records, stored on a blockchain where only you have the key to give a doctor access. It's all about bringing trust and transparency to systems where it's been hard to find. And that's really the big idea here. Blockchain isn't just about money. At its heart, it's a technology for creating trust between people who don't know each other without needing a middleman. It's a way to create a source of truth that we can all agree on. So the real question isn't just, what is blockchain? But if you can build a system based on verifiable truth, what else can you secure with it? And there you have it. That's a simple look at how a blockchain actually works, from the inside out. I really hope this helped clear things up. If you found this useful and you like simple breakdowns of complex stuff, definitely subscribe to the Priyanka the channel. We've got a lot more coming. Thanks so much for watching.